Hey everybody, this is Larry, this is me going Q4 of the weekly contest 358, apply operations to maximize score. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem, or this problem rather. This one, I think the thing that you have to think about is, well, the first thing to notice is the mod, so don't forget the mod. I didn't forget this mod, but I forgot a mod that I'll show you later. I did horrendously during this one. First of all, I'm going to do my little retro postmortem. Feel free to fast forward or skip it a little bit. I actually ended up spending 15 minutes here with 4 wrong answers. To be honest, initially the thing was just that I misread the problem somehow. For some reason I thought in my mind I saw this thing, and for some reason I thought that this just ended up being smaller. So as a result, I thought you could do a heap and just simulate it, right? The idea being is that given a number, you can kind of, you basically there is a sort of a greedy situation here, is that you can kind of keep expanding, right? Like you expand to 11, expand to the right, and so forth, and there's some way to kind of make sure it's unique. But then after kind of doing a little bit of debugging and being silly, I was like, oh wait. This is actually a big number. What am I thinking? I don't know. Well, it's just some days you have one of those days, and right now in New York, it is in my room. It is 82 degrees Fahrenheit, which is for those of you who are sane, is 28 degrees Celsius, more or less. So it's very hot, and maybe that's my excuse. I'm sticking to it, and also I've been fasting. Definitely, maybe I should plan my fast around these. But anyway, yeah. So K is big, so you can't simulate it. So what can you do? Well, I mean, the biggest thing is just figure out the contribution and the final answer, right? Because you have n elements, you can only look at each element at most log n times or something like this. So you have to be able to do it really fast. Yeah. So that's basically the idea, because you can't do n squared. And for this particular problem, you're trying to maximize some score that you multiply all the time. So that already lead itself to be a greedy solution, in that if you do the simulation, you would take the greedy every time, right? And then you try and like put it on a heap or something like this. But yeah, and I think the part that was a little bit the problem that was a little bit hard here was that I think this is kind of a little bit like, I think they could have added some definitions about like chosen previously. They put the definition here after this, which is also a little bit awkward. But yeah, but here the maximum score at most K operation. I also spent some time thinking about what does at most mean, because that you also mod afterwards, so that's a little bit wonky. But of course, you always want to take because X is always at least 1, you want to always take the, you always want to just keep going, because at worst you just multiply by 1, right? So that's basically the idea here. Yeah, so you want to take K of these greedily. Okay, so then now you have to figure out, okay, I mean, I know that I said you have to take each number and then figure out the contribution, but what does that actually mean, right? So what does that actually mean is that given an array, we go, okay, let's say 19, let's ignore the K part for a second, right? Let's say your K is every number, or every pair of numbers, right? So then the question is, okay, how many times does 19 appear in the answer, right? I mean, this could also have been like the sum or something like this, but I think some actually would have been the same thing. Let me know in the comments if I'm wrong about that. But basically, you ask yourself, how many times is 19 in the final answer, right? Well, in this particular problem, we have to do this thing about distinct primes, right? So I don't remember the exact. Do they tell you? Yeah, I mean, okay. Let's just actually, yeah. So in here, I don't know. I'm just gonna make up some numbers. All right. So let's put, so that it's easier to understand or easier to illustrate. These numbers don't relate to each other. So maybe you have some number like 2 primes, 3 primes, 1 prime, 5 primes, 2 prime, 3, something like this, right? Some random number. So then now, what does that mean? So let's say this number, let's not even call it 19 anymore because like just call it A1, A2, A3, right? These numbers don't really. I mean, they matter, but not that much, right? And I'll show you why in a sec. Basically, you're saying, okay, how many times is A1 going to be in the answer? Well, A1 is going to be in the answer if you look to, it's going to be its own answer, and it's going to be in the answer at least once for itself because the sub array where it starts at A1 and ends at A1. And then you ask yourself, how many times can you go extend to the left? How many times you can extend to the right? Well, the count to the right is 3, so that means that if A1 is in the same subarray as A2, it'll never be A1. That's basically the kind of the observation, right? So maybe we'll use a little bit. Let's just change this to a 5 for a second. Let's change this to a 2 and then to a 2 as well, right? Something like this. So using another sample, let's look at A4 for now. The question is, okay, how many times does A4 happen, right? Well, I have this thing I call degree of freedom, but basically it's just how many times can you go to the left and how many times can you go to the right? Because that's basically the number of combinations that you have. So to the left, I forget how it goes. Oh yeah, because basically if they're the same number, it takes the smaller index. So that means that if A4 is in the same array as A3, then it will never be A4. That means that it has to stop here, right? Let's actually make this a 1, and then make this a 1, and then this a 2. So that means in this case now, 1, we don't have to stop here because if we have an array of A3, A4, then A4 will be the answer, or the contribution as I call it. Same as A2, A3, A4, right? And then until it goes to A1. Now if it goes to A1, it goes, okay, this is the same number. They're both 2s, but A1 is the lower index, so it's going to be A1, so it will no longer be the answer. So then now, these are the possible answers to the left that has A4 as the answer, right? And then now we do the same for... so that means that to the left we have 3 degrees of freedom. What do I mean by that? We can choose 0 left numbers, 1 left number, or 2 left numbers, right? And then now we do the same to the right, except for that the ties are. I'm going to just change again these numbers a little bit. Say something like this, right? So this is, like I said, the same thing. I don't even care about these 8 whatever, right? The 2, it can extend past 1. So it'll do A4 of A5, right? A4, A5, A6 as part of the subarray. Because if these 2 are tied, A4 and A6 are tied, so that means that A4 is the tiebreaker, so A4 will have this. So then you kind of keep going. And then now until it goes to A8, where it has a 3, and you go, okay, well, if A4 is in the same group of an A8, then it ties. Right. So what happens now? That means that on the right side, That means that on the right side you can go 0 numbers, 1 number, 2 number, or 2 number extended on the right side, 3 number, and that's it, right? So you have on the right side, as we said, you have 0, 1, 2, 3, right? So that means that you have 4 choices on the right side, and on the left side you have 0, 1, 2, and then you have 3 choices. That means that in total, A4, you have 12 different possibilities, 12 different contributions to the final answer, right? If we take everything, right? So that's basically the idea. And then now we go back to the original problem of, okay, well, now we have to factor in K and how many times that factors into play. So if there's no K, and you just basically multiply everything for everybody and that's it. But because there is a K, what do? Well, as we said, it's going to be greedy because for multiplication, you always want to just multiply by the biggest number, right? So that means that, okay, now let's say put all these together. Let's say A1 has, I don't know, let's say A1 has 10 contributions. I'm just making up random numbers again. So, A2 has, I don't know, 6, A3 has 12, A4 also has 12, and so forth, ... right? So then now, what we want to do is, actually I did it with a heap, but you could actually just sort it, right? Because now you always, no matter how many contributions, oops, I don't know how that happened. No matter how many contributions, you always want to take the biggest number. So then now you sort it by this number, and that means that this number happens 12 times. So that means that we actually want to do A4 times A4 times A4 times A4 ... 12 times. And that means that we do A4 to the 12th, and then greedily, right? Something like this in this order, some prefix of this, right? And then now if you have K, then all it has to do is just take the prefix of this, which is, right? So you take some prefix of this where, if K is equal to 100 or something like this, well, K, that's too big. But let's say it's equal to 5, then you only take the first 5 of A4 and then you're done. If K is, say, I don't know, 18, then you take or 12, and then you take 6 of this, and then you're done, right? So that's basically the idea behind this problem. And I actually, during the contest, did it with a heap because, I don't know, I just did it this way. There's going to be a couple of things that I'm going to say. There's going to be a couple of things that I'm going to say it's a prerequisite that I'm not going to go over for this video just because, this video is already kind of long and, I just want to get to it. But I'm going to, I have other videos for it, but also, yeah. But basically, the first thing I do is Sieve, right? This is Sieve of error. I always say the name kind of weird, but Sieve of error. You get what I mean. You could read, or at least you can Google. So yeah, the idea here is counting the number of distinct primes, and of course you can do this in a number of ways, but this is the way that I did it. The kind of crappy thing about, so I actually got 2 wrong answers on this one just because I simulate, but I simulate incorrectly. So that was just me being dumb. And then after I did the simulate, I'm like, wait a second, K is really big. So I didn't even actually get to the TLE part yet. I was just like, oh wait, T is really big. So I had to rewrite it. So I kind of spent some time rewriting it. But one of the wrong answers is, well, I forgot to mod in one place, so I got TLE not because of the complexity, but because the answer grew so big that it time limits it because, Python has big nums, but it still takes a long time to multiply 2 big numbers. So that's one. But this is the thing that you have to do in Python, which is a lot crappy, which is that I pre-calculate the Sieve only once for every problem input, which you shouldn't have to do, but they make you do it. So yeah, it is what it is. I'm not going to go over that as well, but just know that this is a thing. This is why I kind of wrote it this way, because this is global and I reuse this as a result. Okay. So yeah, so this is the Sieve, and this is the way that I count distinct primes. Yeah, because this loop only starts if you're, this loop only starts if you're prime. Yeah. Otherwise, oh yeah. So I actually skipped a little bit, sorry. But yeah, so now, so this becomes, I explained the logic. I didn't really explain the solving part, right? So the thing to now defining this part is that for a given number, again, A4, what does this mean? So then we're now just saying, okay, for this A4, find a number to the left that is on the count, right? So count, that is, let me rephrase this a little bit. Find the next index to the left that has count equal to or greater than this count, right? And also another one to the right, which is similar but not quite the same, is find the next index to the right that has count greater than, remember this is strictly greater than, this count, right? So these two are similar but not the same. And the way that you would solve this is with monostack. Monostack, I actually have a video on monoq, but it's the same idea. Monostack is just a name for a stack with an invariant. I don't like to talk about it that way, but the idea here is you're trying to eliminate search possibilities, right? That's the idea behind this monostack. That's how I kind of, and if you watch me during the contest, I actually kind of redid everything from scratch on this proof. But the idea here, and maybe I should just have template, but in any case, for this particular problem, basically, if what I mean by doing every possibility in a smart way is that once let's say you have this 1, right, and you're looking at A4, as I said, you're looking at this 2 is bigger than 1. I know you know this, you're smart. No, but what that means then is that 1 can no longer ever be an answer to everything to the right of this 2 either, right? Because anything that is anything that is smaller than 1, or even bigger than 1 in some cases, it's going to be smaller than 2. So 2 is always going to be the next number to consider, because 1 could never be an answer again. So that's basically the idea behind monostack, is that you eliminate these things using a stack by popping them off, because okay, this one would never be an answer again. And also the other thing about this monostack is that, let's say this is a 3. If this is a 3, and you have a 2, well, if this is the next biggest number, you don't ever have to look at numbers to the left of it, because, well, again, why would you have to? This is the next index, right? But the other thing about removing possibility is the way that I want to think about it. So, okay. So now, once again, so I explained this in a weird order. I forgot about the monostack part, or to explain it, obviously. But yeah, this is the Sieve. This is, we'll skip this, the Sieve. Not going to go, just time constraints, right? Consideration. So this is the monostack for the left, as we said. So if the count on the left side is less than the current count, then that means that it can never be the right answer, so we pop. Otherwise, this is the number to the left that we can extend to, keeping in mind that if there are no numbers, you have to kind of do some funky math. So I guess you can use a sentinel. I think that's how some people usually do it. And by sentinel, I mean like you have some like ridiculous, what is this? I don't know. The actual first number doesn't matter because it will never happen. Oh no, this is just the index. The first number is the index, so it's like -1, and then the count would be like 1 billion or something, right? So because it never goes. And then now, if you write it this way, then you don't have to do this, I think, right? Yeah, I mean, during the contest, it's tricky. It's easy to just kind of whatever. I'm not going to do it for the rest. You get the idea behind the sentinel. But basically just keep on going left, and this is the idea behind a monostack. They call it monostack, but as I like to think about it, it's just a stack with an invariant. The invariant being that, you never need to go beyond the first item, and if you do, that item will never be used again. So each item can only be considered, amortized over one time or something like this, right? So that's basically the idea. And then now I also just keep track of the left. So basically left just lets me know for each index how many what I call is degree of freedom that we can have a choice on. This is basically what we said here, which is like, for example, for the A4, this will be 4, right? We do the same thing for the right side. The only thing that's different is this is greater than or equal to, or sorry, less than or equal to, versus just less than. I did it in reverse order as well for obvious reasons, because it's going from the right side. So that's why reverse at the end. I did this heap thing, but it's actually not necessary. Like I said, you can actually just sort. Because I had some other funky thing earlier, so that's why it's done this way. But yeah, you can have just do a sort, and yeah, but basically this is what I said in a greedy way. So we take the X and the count, and we do the greedy, so that's why this part's a little bit awkward, so maybe I could have done it a little bit differently. But yeah, you always do greedy, and then you always do X to the delta, which is the number that you use, which could be either count or K. So I have to look at the tapes to see if I said it out loud, but I was actually thinking very hard on mod pow, but I just forgot to type it. And then I spent so long debugging it. But yeah, I had to mod pow, and that was the TLE one wrong answer. Yeah, and then you mod it afterwards, and then yeah. And while K is greater than 0, and will always, the total of all these will always make this true, then you just return answer. So what's the complexity here? There's this Sieve thing, which is going to be O of m log m, for m is equal to biggest number, right? This is O of n, this is O of n. Oops, I don't know how that happened. This is n log n due to the sorting, even if you use heap, if you don't use heap. I guess technically heap could be slightly faster in that you don't have to use the entire way, actually, but it's more complicated, as you can see, because you don't have to sort the rest of it, right, in theory. And this is linear. I don't know, whatever, right? But yeah, in the worst case, everything together is going to be m log n, as we had before, plus n log n. Yeah, and in terms of space, I think we just use m plus n, right? For the, yeah, where m is the maximum number. So yeah, that's all I have for this one. Let me know what you think. Let me show you the top. As I said, this is the Sieve. I really should have just template this. I don't know. I mean, this is a variation of the Sieve. I think I kind of skipped over it a little bit. But basically, we're counting the number of distinct prime. So that means that if this is a prime, then when we do the order, we just add 1. That's why I'm able to do it this way. Sometimes you do have to make minor modification was to the Sieve. I actually wrote this a little bit differently if you kind of watch the live portion. Yeah, this is the monostack. Get the leftmost. I don't know if you could generalize a little bit. I mean, maybe you can, but there are a lot of, you spend too much time on it during the contest, maybe. This is the sorting and greedy heap. So yeah, like I said, you always take the biggest number, and that's why we take the negative, because we take the biggest. That's all I have for this one. Let me know what you think, and you could watch me solve it live in the contest now. What a sloppy contest for me. Actually, would have been pretty good, to be honest, right? I mean, if I didn't make the 2, I mean, that was a learning mistake. I found this magic until the magic doesn't work. Alright, what am I? K times, what is K? K could be something big. Oh, okay, K could be something big. What's a prime score? Why did they, like, they should define this first? Okay, okay. Smaller than that. Yeah, mod. I feel like this is a hard enough problem that those 2 wrong answers is gonna hurt. Like, no way people are spending 18 minutes on them or whatever with the penalty. Yeah, well. Okay, so we keep on taking care of indexes. The prime is number of distinct factor of x. I mean, that means that we should do whatever first. So we multiply the score by x every time. Can we do greedy? Seems like it's just greedy, right? We just keep on getting max. Maybe? I actually don't know why we don't just do chosen over. The not chosen already part is very confusing. I think that's why it's a little bit like, is it the L and R not chosen completely, or I'm kind of confused. Like they don't tell you what it haven't chosen completely yet. Like, is it each element or is it the indexes? Because this one, sounds like it should be greedy. Like, why would you just not picking 0 and then 0, 1 and then 0, 2 and so forth? Like here. Am I misunderstanding this? They don't tell you what it used being means. Yeah. Why would you not choose 0 and 0, 1? This thing. Highest prime score. Oh, I guess I see, because 0, 1, 12 has a prime with higher prime score. Okay. Seems like it's a priority queue thing, but you still have to kind of process it. That's a. You always start with one element. I think that's the thing. Okay, fine. Yeah, I'm so far behind because of the 2 wrong answers. It would have been like top 10 or something, but silly Python. Okay, focus. Do I have time to? What's 10 to the 5th square root of that? 316 times. Yeah, I guess that's too slow. We have to do it Sieve. Technically, you could do this. Yeah, it's been a while. I'm so bad at this. You could technically do I plus times 2, but whatever. Okay. Number of unique prime factors. Okay. I feel like some people pre-calc this. Hopefully I don't need to pre-calc this. If I get TLE, I'm gonna be sad. But okay. And now I think I waste a lot of time on these problems. I'm just kind of messing around too much. Let's see. Oh, I don't add, do I? Yeah, Okay, fine. So this is the okay, fine. I think I don't need to do this, but I am. I think I'm just being dumb. I don't know if I'm off by 1. Though I guess off by 1 doesn't matter because it's all going to be. Because you're supposed to sort it anyway. Okay, so. Okay, so I am off by 1, but I think that's fine. What's 12 again? 12 is 2 and 3. Yeah, 2 and 3, right? That's okay. That actually matters then. Okay, so that's 2. Okay. Have you gotten this yet? It shouldn't be that bad. I feel like it's either that or I'm wrong. I think that's the thing. If I'm wrong, I'm wrong. Because if it is the way that I'm thinking it is, then it shouldn't be that bad. Okay, so the heap should look like. What's my stuff? The current number. What am I doing? The current number, which is num sub I. The distinctive. What does the distinctness matter? The distinctiveness don't matter, I don't think. Okay, fine. It only matters when you want to expand. Okay. X. And then now, okay, if okay, I don't think that matters. Yep. So this is good. You extend to the right only, right? You want to extend to the left? Yeah, you want to extend to the left. Because basically 18, you want to extend to the left if it had fewer primes. Yeah, okay, so that makes sense. Okay. Count. Maybe I do something like if this is, if the count is greater than score, then we should try it. And we can expand to the left. With the same score. If it's equal to as well, then on the other side. Yeah, okay, that makes sense. That's not right. Okay, let's take a look. What is this doing? Oh, it's a min heap, Larry. It's a min heap, Larry. I always forget. Sometimes I just think the heap will do exactly what I want it to do without remembering whether there's a min heap or max heap. Alright, let's see if this works. Oh no. Well, at least that's a fast no, and not like, you know, it's good. What's this? I don't know. Is that good? I did the moderate, right? Okay. Oh, at most K up, right? This is kind of cranky. This is going to be is it impossible? Well, not to these people. Because what does maximum possible score mean if you're going to mod it? K, this could be how big of a number can it be? 10 to the 5th to the K power? Are you serious? Like, I don't know if that they're just being wrong, to be honest. Well, I mean, not that my intermediate results would have been better, but this is just so weird. This is impossible to debug, maybe. 332223000111. I thought it was close, but I don't even know what that means. There's so many things about what this problem is so underspecified. But what am I doing wrong? Am I wrong? Left, right scores. This one has 4 primes. It's just primes, right? And I am adding just the... Oh, actually, am I adding the prime? Yeah, I'm only adding the prime. This should be okay. Take a look real quick. Yeah, that looks okay. My code here should be good. Okay, so oh right. So we do this first because that's 4, as this because that's 4, and then it extends to the right. And then now, is it true? I don't think, actually, I don't think this is right. Why wouldn't it be 1? This should go 1, 3, so definitely there's something wrong here. Because this number is pretty big. Let's see, what am I doing? Count. Oh, I had this wrong. Oh man, that is a silly typo, isn't it? How does that pass the examples? I guess just lucky. Hopefully this doesn't time out. If it's timeout, it's fine. It's just I have to do that Leetcode pre-cache thing. Oh. Huh? Dong dong dong. Alright, well here we go again. Here we go again. So many wrong answers because I suck. To the left. Expand something. No, because if it's Leetcode then you're okay. What am I doing? Oh, 16 instead of 28. Why is this? It's off by a little bit. But that doesn't even make sense. I mean, I think the up to K part is a little... No, you always want to increase, so I feel like you just kind of... It's always at the end, because you always want to increase, and all your answers always increase. So, at most part, I don't think it does anything. Instead, I'm just wrong on other stuff. Is this wrong? Is this wrong? Oh, 1 is an input. Oh, 1 is an input. Five times 4. But we should be wrong another way. Why am I 0, 3? Am I expanding right? So the current score is greater than or equal to the right. That's fine. That means that we get the current score. To the left has to be exactly greater. Yeah. Actually, I want to see something. I think that's the only case. 5 times 4 is 20, right? 5 times 6 is 13, 15. I feel like some of this should give me like a 0 answer, just from this. Oh no, just multiplying by 1, I suppose. Is it giving me the same answer? It's not giving me the same answer, which is kind of weird. That means that I'm doing something duplicate. I'm doing 0, 2 twice. Why am I doing 0, 2 twice? Tell me why. That is why I have a wrong answer. Okay, now I see it. Because 0... Oh no, this isn't 0, 1. This is... X, left, right. No, that's right. We are doing 0, 1 twice. I should label these. But why am I doing 0, 2 twice? So we start at... Where's my 0, 0? 0, 0 is not coming to play. 0, 1. Oh, because they're the same number? No, that's not right. 0, 1 is 0, 1. And then we expand. Oh, wait, what? Actually, this times out anyway, Larry. What are you doing? I am pretty bad at this. I realize I just read this wrong. So this would time out anyway because of my heap. Okay, so we have to do a little bit smarter than that. Man, this is just a contribution thing, but I think I'm just today having a bad day. I had totally misread this part and I was just doing well. Okay, rethink. I have to reset. This is a tough reset, but I have to reset. Reset. Okay, number of contributions. So basically, okay. I mean, you know what you're doing. You just have to simulate it, and I just did the simulation part. So okay. So Okay, what are you doing? Focus. Okay. This was going to time out, even though you make mistakes anyway on your simulation, but this was going to time out. Okay. This is bad. But basically what we're doing is for each number, what is its contribution? If the number extends to the right, today is a rough day. Okay, contribution. Oh man, why I misread the constraints. Okay, I don't... the min confused me, I suppose. Okay, focus. That part is the same. That's a contribution. Alright, so if this is the leftmost, how many pairs can it be in? So the left, it extends, and then the right, it just extends, right? So I'm so bad at these problems. Okay, so then now okay, so how far does this extend? So on the left side you have, and then you do degree of freedom. That's right. Okay, I get it. So the naive, you just kind of do a loop. Of course, that's n squared. So now we have to get the... So let's see if we count away. We have to get the last number that is... We have to get the last number that is greater than. We have to get the last number that's bigger than. That's a mono-Q thing, right? So, okay, last number that's, or equal to, actually. Yeah. So this number contributes to the last number that's this number or equal to. So you have, okay. Now, is it? Oh man, I'm so bad at this. I'm so thrown off. We have an hour. I could solve this. It's solvable. I'm just being dumb and slow. Last number that's greater than this. So then you have a... So while is less than no, counts of I, because if the equal we stop, so then here we stop, right? It's either that or -1, so okay. So basically q of, oh no, not q of 0, the last number. I will q, but I think it's a stack. Let's see. Q, this minus I, so we have this degree of freedom on here. Pop. Right. And then we append, let's see, this number. What am I doing? I is on the third, counts of I, right? Okay. I'm so dumb. I'm just not focused correctly. Oh yeah, if length of q is greater than 0, you know it's a stack. Otherwise we append I suppose. You may be off by 1, I have to think about that. I should have kept all the other ones too, but it's fine. All the inputs. I think I had this one, so I could use it for my, but that's fine. I don't even know what the answer should be, so it doesn't even matter, as long as it's reasonable. Okay, so these are the counts. And so then here we have 1 to the left. Here we have also 1 to the left. Technically it's this -1, I suppose. Yeah, it's this -1 for, no, this is degree of freedom, that's fine. Because we have 1 degree of freedom, okay. Yeah, and then 5 has 1, so the 2, okay. These are kind of actually terrible examples to do. 6, what is 30, what's the other one, 10 maybe, okay. Okay, so 1 2 3 4, 1 2 3 4, okay. And then now something like that maybe. Just want to make sure I'm right. Okay, 3 2 3, okay, should be right. And then now why am I so silly? Again, this is a stack, but and now with the equal we keep going, so that's always fun. Is it I minus the front, right? So it's actually q -1 2 minus I. Is n minus I actually? Hopefully. Okay. Okay, and then now we have a heap. We want to say what are we saying? Nums of I, and then the number of lefts of I times rights of I, right? And we want a max heap. So yeah, let's keep it a max heap. I think the tiebreaker on this actually doesn't matter, so it's fine. Famous last words, and I should use heapified, but it's fine. while k is greater than 0. Yeah, okay, fine. I'm just gonna modify this. This is where things goes wrong, but well, I mean, things have been going wrong. So yeah, so x and then count is equal to this. X is equal to negative x. We don't need to use it again anyway, but okay. So then delta is equal to min of count k, and then basically we want to say answer. We want to do it on mod pal. We do x delta times, and then k to the delta, and then also do a mod. Why not? Index out of count. That's odd, isn't it? So each number should, I mean, the total should be whatever, 6, 9, 11, 15. This is for 6. Am I off by 1 somewhere? It certainly maybe I am off by 1 somewhere. Okay, that's just, I think the right stuff could be wrong. Right. What a silly mistake though. Okay, so there's 1 degree of freedom, 2 degree of freedom, that's right, 3, 4, 5, and this is 1, that seems right actually. This is 2 degree of freedom because you could take 1 and then 0. Yeah, okay. Yeah, I think that's right. So what is wrong? Tell me why. Why is this 0? Left is that may be why. This is off by 1 maybe? Yeah, this is off by 1. Oh, this is I plus 1. Yes, okay, that's why. I don't know if this is right anymore. Should be okay. I mean, I don't remember the answers, so YOLO. Is this gonna be like if this is 1 at a time? No, that shouldn't be. That shouldn't make sense. That's the only thing that could be maybe. If delta's no, because it's still like n log n. This is only n entries. So what can be long? Please stop. Stop. My this and I. Why is this? This cannot be 0, right? I plus 1, this has to be greater than 1, and this has to be greater than 1. This is greater than 1, so okay, so this cannot be 0, I don't think. Why am I getting time limit exceeded then? This simplify. Do I have something silly like here? I don't think so. Maybe the set. The set is kind of a clunky part, to be honest. But I haven't even finished it, but my Discord is going nuts. Okay. Does it tell me the time? Oh, it does tell me the time. I don't know. I mean, I guess the worst case is just maybe like how many. 10 to the 5th is a ridiculous number. You can't even test it. I guess you can, but let's see. Let's take a look. Oh, because maybe this stuff. Let's see. This is just wrong, right? No. But I am doing repeated things, but I don't think that matters that much. But I guess maybe it does, so. Let's see, right? So. Okay, I guess that's what I really need. Whatever. How long does that take? 4 examples of it. It's slow, but it's not like unmanageably slow. This part's always a little weird though. Because this is not the number of unique. Can I write this in such a way that it's not? Oh yeah, I guess so. I mean, right, and then now this is num sub I. Count of I. I don't know why I wrote it this way. Maybe I should have just had a different thing because this is so easy to kind of. I guess that's it really. Is this faster? It's slightly faster, but. How do I do this? I don't know how to. How do I do this again? Something like this, maybe. I think it's kind of crap that you have to resort to it, but still. An object not. Line 40. I am just doing a lot of silly things today. It's fine. It's just one of my 4-way contests. But what does that mean? Why is nums? Do I do something weird? Int object not subscribable. So that's not that. Huh? What does that even mean? Maybe I should have done something like that, and then it would be more obvious. But oh no. That's good. Oh. I don't know what. Maybe count. It's a cause global count. It could be a global function or something. Is this right? Oh, because now this isn't true anymore. This is this. That's fine, I guess. Okay, now this is fine, and I think this actually is slower than before. But let's see. Let's have this, right? Is it faster? It's like marginally faster. But I guess if you have enough big test cases. I mean, this is as slick as it's gonna go, I think. Let's give it a submit. If it times out, I have to figure out. I mean, either that was just some like weird case. Maybe it's a weird edge case issue. Maybe I'm just wrong. Yeah, maybe it's not this weirdness. Maybe it's just an edge case issue. That doesn't even make sense. This part shouldn't do anything. Unless my math is wrong, and then alright, total 0, 0. What is it? N times n. Something like this. So that's right. It must be some weird thing where this is not finalizing. Let's see. What if it's exactly... Am I off by 1? Yeah, that's what I thought. So why is this... What am I... Oh. No, this doesn't make sense, right? What am I debugging? I don't even know why it's debugging. Is it slow at least? If it times out, that would be interesting. Okay, so that's good. In that I don't know why this times out. Why does this time out? Because the K is too big? I guess I was wrong. I said that this doesn't matter if we choose the biggest or smallest, but I guess it does a little bit. Enough that I explicitly said it didn't matter, and I guess it doesn't. But I don't get it. This should only pop 100,000 times. So why does that even slow? This is still too slow. I don't get it. Yeah, I don't think it mattered. Because it should just be at most. Why is this so slow? Like, I don't get it. Why is this so slow? Like, if I get rid of this, is it fast? Yeah, I mean, it's reasonable. Why is it so slow? It's just... Do I do something funky? It's just 100,000 heap, right? But that doesn't even matter, the heapify. I don't get it. I won't do anything. Oh, I am dumb. I specifically wanted to mod pow this. Oh. But then I think I just forgot to actually write it in. I can't believe I actually forgot to write it in. Okay. Yeah, okay. I don't need to see this print now. Oh my. A lot of a lot of mistakes today, I suppose. Yeah. Oh my god. When I was writing it, I was thinking about it. I was like, oh, this is perfect time to use my POW. And then I just forgot about it. Oh my. A lot of silly mistakes. Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, thanks for your support. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.